2020 Canadian Open Mathematics Challenge, Part B. The set S contains 6 distinct positive integers. The average of the two smallest numbers is 5, and the average of the two largest is 22. What is the greatest possible average of all of the numbers in the set? Okay, so let's say we have a set, and they're saying 6. So A, B, C, D, E, and F will be the letters to represent those 6 numbers. And then they're telling me that the average of the two smallest, which I will call A and B, is 5. So that means A plus B over 2 is equal to 5. And A plus B is equal to 10. And then they tell me that the average of the two largest, which I will call E and F, that average is 22. So E plus F over 2 is equal to 22. So that means E plus F is 44. Okay, so what do they want? They want the largest, greatest possible average of all the numbers. Okay, so basically what they're saying is, if you take the average of all these guys, what's the largest it could be? So A plus B plus C plus D plus E plus F all over 6. What's the largest this could be? Okay, well, A plus B is fixed as 10, so these two guys are 10. And then these two, E plus F, is fixed as 44. So I guess the only thing, and then the denominator is fixed as 6, obviously. So the only thing I really have to, I guess, maximize is C plus D. Well, these are all integers, right? And they're also distinct, meaning that none of these are the same. So let's see what's the maximum I can make C and what's the maximum I can make D. And concentrating on E and F. E and F is 44. So I want to make E and F as large as possible so I can make D and C as large as possible. So, for example, if I were to make E 21 and F 23, they would indeed equal 44, the sum. Because I can't make them 22 and 22 because they have to be distinct. So that's not possible. Okay, so if I make E21, then I could make D20, and that's the largest I could ever make it, and I could make C19. And that's basically how I would do this. So therefore, C plus D is going to be 19 plus 20, which is 39. And therefore, this is going to be 54 plus 39, which is 93 divided by 6, and that is 15.5. Alice places a coin heads up on a table, then turns off the lights and leaves the room. Bill enters the room with 2 coins and flips them onto the table and leaves. Carl enters the room in the dark and removes a coin at random. Alice re-enters the room, turns on the light, and notices that both coins are heads. What is the probability that the coin Carl removed was also heads? Okay. So let's just talk about this very briefly. We have coin 1, and that is heads. And that's Alice. And coin 2 and coin 3, that's Bob. So what's happening here, just like the question says, Alice places a coin heads up, and that's why I put heads there on a table, and then turns off the light, leaves the room. Bill enters the room with 2 coins and flips them onto the table and leaves. So his 2 coins I've represented as C2 and C3. Carl, so I guess C for Carl, I'll just write out his full name, then enters the room and removes a coin. So he removes just 1 coin. Removes 1 coin. And then finally Alice comes back, turns on the light, and notices that the remaining 2 coins are both showing heads. So that's the scenario. Okay. So then they're asking is, what is the probability that the coin Carl removed, so that Carl, was heads? Okay. So we've got, I think, 3 scenarios. The first scenario is when all C1, C2, C3 were heads. So this is my C1, this is my C2, and this is my C3. Okay? And then how many ways can we remove one coin? Remove one coin, which is basically what Carl does. Well, there's 3 ways, right? The C1, you can remove C1, you can remove C2, or you can remove C3. And regardless of which one, in the end, you're going to have 2 H's, which is what you want. So that's scenario number 1. Second scenario is when C1, C2, and C3 are H, H, and T, like that. Because H is fixed for C1, right? As you can see there. That's C1 is always going to be H, so we can't really do much there. But with C2 and C3, that can change. So that's why I made this scenario. Then again, you remove one coin. And how many ways can you remove one coin? Well, we got to be careful here because we have to make sure that at the end we have 2 H's. So therefore, the only way we can do that is if we remove the C3, which is tails. Okay. And then finally, the last scenario is very similar. C1 is fixed as C1. C1 is fixed as a head. And then C2 this time we make tails, and C3 we make heads. Very similarly, you remove one coin. And again, we have to ensure that we end up with 2 H's. So the only way to do that is if you remove C2. And there you go. That is the third of the 3 scenarios. Okay, now we go back to our question. What is the probability that the coin Carl removed is also heads? So these are the coins that Carl removes, right? So the probability is always a fraction, unless it's 1 or 0. And in the denominator, it'll be the total number of cases. So in total, we have 1, 2, 3, 4, 5. So 5 goes here. The numerator is our specific condition, and that in our case is that it has to be a head. Carl has to remove a head. So how many heads are there? 1, 2, and 3. And that's it. That is the probability. 3 circles with the same center O and areas 2 pi, 3 pi, and 4 pi are drawn. From a point A on the largest circle, tangent lines are drawn to points B on the middle circle and C on the smallest circle. If B and C are on the same side of OA, find the exact value of angle BAC. Okay, well, the first thing I'd like to do is draw some lines to make these into triangles, and in particular right triangles. So the first one is going to be O to B, like that. And the second line will be from O to C. Yeah. And what that does is it creates 2 right triangles, because remember, these are tangent lines, and as you know, those tangent lines create right angles. So that's a right angle, and that's a right angle. Okay, so now we can use trigonometry. In triangle ABO, we have to look at that triangle and talk about the angles. So let me label some angles here. The one that is this one right here, that small one, I'm going to call theta 1. And this angle in here, I will call theta 2. This one, that one there. Okay, so now in triangle ABO, the sine of theta 1 plus theta 2, that whole angle, will be equivalent to, using basic trigonometry, opposite over hypotenuse, right? So OB over hypotenuse, which is OA. Okay, and then very similarly, in triangle ACO, we again might as well just use sine. Sine of theta 2, again opposite over hypotenuse, would be OC over OA. And I think that's good enough. And now we just have to figure out what is OB, OA, and OC. And that shouldn't be a problem, because they told me that the area of the small circle is 2 pi So that's going to be pi r squared. But r in this case is OC. So that means 2 is equal to OC squared. So therefore OC is root 2. In a very similar way, we know that 3 pi is the area of the middle circle. So that's also pi r squared. But this time that radius is OB. So OB is equal to root 3. And 4 pi is equal to the area of the biggest circle. And in that case, the radius there is OA. So that means OA is equal to 2. So we have the values. OB, therefore, is root 3 over 2. And OC over OA would be root 2 over 2. Well, good news is that, root 2 over 2 here. Root 2 over 2. Okay. Well, the good news is that these are well-known values. If the sine of something is root 3 over 2, then you should be able to know that in your head without a calculator. That means that angle, in this case, theta 1 plus theta 2, is going to be 60 degrees. And for this one, theta 2, root 2 over 2 would make it 45 degrees. Okay. So what do they want? The exact value of angle BAC. So BAC. And BAC is what? Theta 1, right? Yeah. So angle BAC is theta 1. Okay, well that's just theta 2 plus theta 1 minus theta 2, right? Well, theta 2 plus theta 1 is 60. Theta 2 is 45. So that means this is 15. 15 degrees is the answer. An ant walks from the bottom left corner of a 10 by 10 square grid to the diagonally opposite corner, always walking along grid lines and taking as short a route as possible. Let nk be the number of different paths the ant could follow if it makes exactly k turns. Find n6 minus n5. So let's put in a graphic that shows this grid, and then we can talk about it. So in the first one here, the number of turns is 1, 2, 3, 4, 5, 6. So here k is 6. The next one, number of turns is 1, 2, 3, 4, and 5. So here k is 5. Okay, so that's basically the scenarios. Now, when k is equal to 6, the number of I guess horizontal paths, here's one, here's second one, here's the third one, here's the fourth one. Those horizontal paths I will call A1, A3, A5, and A7. And those have to add up, obviously, to 10, because that's how you would get from one end to another. And in a very similar way, the vertical paths, which are, of course, this guy here, and this guy, I will call A2, A4, and A6. And those ones also add up to 10. A2 plus A4 plus A6 also add up to 10. Okay? And in a very similar way, for K5, we have the same kind of story. I will have A1 plus A3 plus A5 add up to 10. Those are, of course, my horizontal paths. And then my vertical paths will be, I'll call them A2 plus A4 plus A6. Those also add up to 10. Okay, so now we have to figure out, how does this work? In the sense, like, how do we calculate the number of different paths? What they want, the number of different paths. Do you do it manually, which would take a long time? Well, fortunately, there's a nice way, and I'll explain it to you. So first, let's draw in 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, I'm going to concentrate on this guy first, but the other ones are very similar. I want 4 numbers to add up to 10, and I'm asking how many different ways are there to do that? Well, if there's 4 numbers, that means I have to divide this 10 into 4 segments. So I'll do that by drawing 3 lines. 1 line, 2 lines, and 3 lines. Now, what I've essentially done is I've created 4 segments. This is A1, this is A3, this is my A5, and this is my A7. Exactly what I have here. And I also did it in a way that it looks exactly like this, where that's 2, that's 1, that is 6, I believe. 1, 2, 3, 4, 5, 6. Yeah, and that's 1. I purposely did it like that. Okay, now how do you figure out the number of different ways of doing this? This is just one way of breaking up, the 10 into 4 different numbers. So in this case, it was 2, 1, 6, and 1. But I'm sure there's many others, right? So how do we figure that out? Well, you use choose notation. So how you choose notation is how many these red bars that I drew, right? I drew 1 here, 1 here, 1 here. I drew 3 red bars, correct? Well, how many possible spaces are there for those red bars? Well, there's 1 here, 1 here, 1 here, 1 here, 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 and here. So a total of 9. So from those 9 possible choices, I have to choose 3. And that is how you'd calculate it. 9, choose 3. Okay? So this guy down here, essentially, is 9, choose 3. That's the number of different ways of doing this. And for here, this guy, it's 9, choose 2. Now, if you're not sure, I'll just do that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, we have to break it up into 3 different numbers, right? A2, A4, and A6. Okay, so I'll put 1 red line here. I'll put 1 red line here. And I did it exactly the way it's here. This is 2, this is 6, and this is 2. So this is 2, this is 6, and this is 2. This represents my A2, this represents my A4, and this represents my A6. So from the 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 possible places to put that vertical bar, I have to place the vertical bar in 2. 1 here and 1 here in this example. So that's why it's 9, choose 2. All right, so hopefully that made sense. And then this one, of course, since you're an expert, that's 9, choose 2. And this is also 9, choose 2. Okay, so now let's put this all together. The number of ways of doing this would be 9, choose 3 times 9, choose 2. You have to multiply them. And when you do that, you get 84 times 36. And yeah, 84 times 36. And then this one, you would do 9, choose 2 times 9, choose 2, which is 36 times 36. Okay, but here's the thing. We have to ensure that we take into consideration that we could also have gone in the other direction. So, for example, in this one, you see how we started off going in this direction. We could have started in that direction also. Similarly here, we started in this direction, but we could have gone in that direction. So because there's 2 possible initial directions, each of these have to be multiplied by 2. So we have to say 2 times 84 times 36 for the total number of cases. And I think that's the part of the question that a lot of students might miss. So same thing with here. So there we go. So this one down here is basically N6, right? Because this was K equals 6. And this one here is N5. So finally, what do they want? They want N6 minus N5. Okay. n6 minus n5. That is going to be 2 times 84 times 36 minus 2 times 36 times 36. And therefore, what's that? 6048 minus 2592. And that is 3456. And that is the answer. Consecutive numbers, interestingly.